this section is called the absolute value functions. So we are doing both equations and inequalities all at the same time. So here, if I have example 5a, I want to solve this inequality where I have the absolute value of 2x plus 1. We're digging on this one just because it's nice to make the connections with everything, is greater than 7. Okay, so let's dig back in the recesses of your old brain. And within those recesses of your brain, you know something about inequalities. With your inequalities, then I'm going to think, okay, so let's step aside for here for just a second. Back to good old side notes. So you know, or you remember, or if you don't remember, now you're getting it. Any of those scenarios. With inequalities, remember if you were to have something like negative 2x is less than 6 or something. What happens to this inequality when you divide by that negative number? Yep, you flip that inequality. So anytime you multiply or divide by a negative number, you flip that inequality. That's what ends up happening there. The same concept is going to pull this off. So if I'm laying this out, I'm saying that my inside over here has to be positive and negative, right? That's the kicker. That's what we're looking at. So that means I have this 2x plus 1 is greater than a positive 7, or this 2x plus 1 is less than negative 7. You always want to come in here and flip for the negative. That's what you want to do. Flip for your negative. Because it's the same thing as solving these inequalities. Oopsie daisy. It's the same thing as solving these inequalities. You want to flip for that negative. When you're looking at that inside being positive and negative, you just want to flip for your negative there too. Now solve. I'm going to subtract 1 again. We've already done this, so we should be good with it. Divide by 2. X is greater than 3. And when I come over here to this other side, I'm going to subtract 1 from both sides. 2x is now less than negative 8. When I divide by 2, x is now less than negative 4. Here, I divided by a 2. As long as it's not negative, then your sign stays the same. When you start looking at something that's negative, that's whenever your sign is different. All right, check this out. Whenever I go to put this on a number line, so I can figure out my set notation, I have a negative 4. We've got a 0 in here somewhere. And then I've got this positive 3. This is telling me my x values are larger than 3 because it's greater than, right? So if x is greater than 3, when I'm looking here, I want to shade to the right because that's where my values are greater than 3. Okay, and x is less than negative 4, so it means it's smaller than negative 4. So I'm shading to the left of that negative 4. Look at your symbol. When you have a greater than or a less than sign, you're using parentheses. If it were or equal to, then we would use a bracket, right? So we're just bringing it back, that set notation, trying to remember how that works. So if you have that sign, this is going to be a parenthesis. And then you write your set notation. Set notation is a direct write out for what you have. Well, here I'm going from negative infinity because it's going all in that back direction. So from negative infinity up to negative 4, parenthesis. When you jump between two values, you do the union symbol, right? So you remember that? When you jump over, you're doing the union because I'm connecting these two pieces. And then parentheses from 3 to infinity. And then there you have it set up with interval notation in order to write out your solutions. So what we're saying, the solution to this, so what are the values of x that are going to make this true? Well, anything that is less than -4 up to but not including -4. And then anything up to but not including 3 on to infinity. Cool, right? Nice. Let's do 5b here. By that same rationale, I can have the absolute value here of 2x plus 1 and see what's happening with it less than 7. Let's see what's happening whenever I change that inequality symbol around. Same thing. You're going to do the exact same scenario every single time. You break it up. Anytime you see that absolute value, you break it up into positive and negative. 2x plus 1 is less than 7. And 2x plus 1, because it's an inequality, you flip for the negative. Is greater than -7. Solve it. Subtract 1. Divide by 2. Subtract 1. Divide by 2. And now let's graph this. Here we still have the -4. We got a 0 in there somewhere. And we have a +3. So I want to say what's happening here. X is less than 3, so smaller than 3, and bigger than -4. So look what just happened there. The values that work are in between this time. So for interval notation, I'm going from -4 to 3 because I've shaded between them. So not only is this good to be talking about our absolute value and how that works, it's also a nice review because interval notation and working with inequalities is prerequisite information, but it's also a nice good review to come in and remember what's happening with that, right? So here's the moral of the story. I'm saying my absolute value is bigger than my number. Well, what happens when things are bigger? They go to infinity, and that's where it goes outside. If my absolute value is smaller than my number, then it's on the inside and will always be between those two. Just so you know, that's always going to happen. If my absolute value is greater, you're going to go this or statement, you're going to shade to the outsides. If my absolute value is smaller than, then it's going to be in the middle. If you ever end up going where my shading goes in the same direction, you did something wrong. Most likely, you did not flip for the negative. So pay attention to that. All right? It's either going to shade to the outside or you're going to shade to the inside. Those are your two choices. And those are the only ones you have. Cool. Let's do some more. What if I have this? Example 6. I have the absolute value of 4 minus 3x, those are absolute values, is equal to 2. Okay. And we're going to do this exact same thing with greater than or equal to, less than or equal to. All right, let's do this thing. So, absolute value, I know I'm splitting it up. So I end up with 4x, sorry, that's wrong. Try again. 4 minus 3x equals 2, and 4 minus 3x equals a -2. Splitting it to the positive and the negative. Then solve. Subtract 4 from both sides. -3x is equal to a -2. Divide both sides by a -3. Negative divided by a negative is a positive. So one value is 2/3. Subtract 4 from both sides. -3x is equal to a -6. When you divide both sides by a -3, you get 2. So my solution here are 2/3 and 2. That's a solution. Because of this equal sign, I'm not worried about what's greater than or less than. At this time, it's just an equal sign. So that is where the 2 crosses this absolute value. All right. So let's do these other ones. How is this going to differ when I talk about part B here, where I have the absolute value of 4 minus 3x is greater than or equal to 2? Well, let's split it up, shall we? 4 minus 3x is greater than or equal to 2, and 4 minus 3x is less than or equal to negative 2. Remember to flip for that negative. Now, from what we just talked about, the fact that my absolute value is greater than negative 2, am I going to be shading to the outsides or am I going to be shading to the inside? Yes, to the outsides. It's greater than negative 2, or pardon me, greater than 2, so I'm shading to those outsides. Good. It's always nice to just have that check in there in your mental capacity just to see what's going on. Let's see how this pans out. So I'm going to subtract 4 from both sides. I have negative 3x is greater than or equal to negative 2. Now check out what happens. I'm dividing both sides by a negative 3. What happens with an inequality when you divide by a negative? Flipperooski, baby. So x is now less than or equal to, because you have to flip that sign, this positive 2/3. All right. Do this other side. When you subtract 4 from both sides, negative 3x is less than or equal to a negative 6. Again, I'm dividing by a negative 3. Pardon me. So I have x is now greater than or equal to a positive 2. If you have an inequality, you need to put that on a number line and see how it works out. So I've got 2/3 here. And I've got 2 zeros over here somewhere. I always like to put 0 in there just to keep my bearings. And then this is saying that x is less than or equal to this 2/3. So I'm going in this direction. X is greater than or equal to 2. So I'm going to the right. What symbol are we using with that or equal to scenario? Bracket. Right on, right on. So I actually have the solution of negative infinity to 2/3 bracket union with bracket 2 to infinity. Good. Good. Last but certainly not least, we get to go the other direction.